Morning, dear students. Hope you are good and listening classes very well. And here we are discussing water supply and various issues that are associated with this water supply. We are discussing class after class. See, when we have a look over there, where what we discuss the past classes, that is the first topic, necessity and importance of protected water supply, we have discussed. The second topic, objectives of protected water supply system, waterborne diseases. In that we have seen the diseases associated with bacteria, viruses, of course protozoans. Followed by we discuss role of environmental engineer, and we also learn flow chart of water supply system or water supply engineering. Followed by we learn what is water demand, various factors that are influencing water demand along with types of water demand we have discussed. And we also discuss the topic name per capita demand, and we learn the formula to find out the per capita demand of various towns with respect to the population. We have discussed design period, and we also discussed factors influencing design period like lead time, economy, population, expansion feasibility, and also we learned estimation of water demand. Along with, we are there in the topic population forecasting, which is connected to water supply system. In that, we have learned, or else we discuss, three methods: arithmetic increase method, geometrical increase method, incremental increase method. See here, we just discussed with a problem that is available in your textbooks. Later on, we will practice various such type of problems when you are starting regular sessions in the classroom. Because of the consequences and because of the problems associated to practice in the online sessions, I just taken an example from your prescribed textbook and explained how we can estimate the population for various decades. Once you started to come classrooms or as classroom sessions, we will practice all these methods with real-time problems to find out the solutions in the name of population forecast. See here, we discussed almost three methods: arithmetic increase method, geometrical increase method, incremental increase method, and we are going to discuss the next method is graphical method. I said if you have any doubts, you are more welcome, and you can please contact me either through mail or message or phone call. See here, and one more thing I'm clearly insisting, please fill the Google Forms after the session what I'm sharing in the classroom. Those are mandatory to find out your status and to retrieve your attention toward the classes. That's why every time I used to post Google form with respect to the content what we discuss in that particular class. See here, we are in the method graphical method. By the name itself, by the title itself, we can estimate easily what we are going to discuss. Graph. In the previous case, we have discussed some the name by incremental increase, geometrical increase, something like that. Here, we are clearly able to understand this method is going to represent with respect to graphs. Here, the population of past few decades will be plotted correctly with respect to the scale that we are going to take up in the graph itself. See here, based on the graph, we will extend the future, or as we can predict the future population by availing the population of past decades. For this method, we need to have experienced purpose who can justify properly, because we are not going to calculate, we are not going to use any calculations here. We are just calculating, or we are just assuming with respect to the graph where we have the population of past decades. Understand? See here, for that, how can we go for this method? Simply here, I just mentioned here, the best way of applying this method is to extend the curve by comparing with population curve of some other similar cities. How can we go for this graph? See, once I have the similar, see, once if I want to find out the population of next decade of X, I need to compare, I need to have the data of the similar cities like X, so that I can extend the graph with possible predictions. See, have a look over here. See here, see up to here, 1951, 61, 71, 81, up to, if I have the data of course, 2021, I can predict the population of 31 and 41. Or else, see here the uniform raising of graph. See here, at one particular period, the graph becomes neutral, that we are going to discuss in another topic, the extension curve of population. Up to one particular extent, the graph, the population of any particular area will be increased. Once it reaches to saturated stage, it's automatically it started decrease. That means that is the saturated stage where we can discuss the days to come by name S curve or as extension curve. See here, population is increasing like this. Once I have the data of past decades, which are grown up in a similar method, when compared with the population that is going to be predicted for one particular area, which has the similar features of the already extended population city. One more time. To find out the population of one particular area, I need to take the data of the areas which are closely resembled to the area whose population is going to be predicted. By taking the consideration of the population of the similar areas, I can predict the population of the similar city or a similar area. That's what I am mentioning here. The population curve of some other similar cities having the similar growth conditions will be taken as in a blueprint, will be taken as input, and I can predict the area which is having the similar features where the population data is available. That is what about graphical method. And next one is comparative graphical method. Here we are just predicting the future population by taking into the consideration of the similar city. Now here comparative graphical method. This is also very close to the previous method. See here, comparative. In this method, the census populations of cities already developed under similar conditions are plotted. The curve of past population of the city under consideration is plotted on the same graph. The curve is extended carefully by comparing with the population curve of some similar cities having the similar condition of the growth. One is we can extend the graph, and another one is we can compare the graph of the already existed cities, and we can go for the prediction of other city. Here with respect to graph, here with respect to comparison. Next one is See here, the advantage of this method is that the future population can be predicted from the present population, even in the absence of some of the past census reports. See here, all the report must be having in this method, whereas in this method, even though we may miss the data of past census reports, we can go for the possible prediction. Understand? These two methods are closely resemble graphical method and comparative graphical method. In the graphical method, see, simply we are taking into consideration of graph, whereas in the comparative graphical method, we are taking into consideration of the population with respect to volume and also graph. Next one is master plan method. In this master plan method, we are going to learn the any city or else normally the cities or else metropolitan cities may have the master plan with respect to extension of boundaries. Once they have the master plan, see, and up to what years, see, the master plan will be prepared for the coming 25 to 30 years for a city. See here, as per the master plan, the city will be divided into various zones like industrial zones, commercial zones, residential zones, like that. Once one zone is filled up, the further zone will be initiated to start. What I'm speaking is, once the one zone is finished, in the sense, how much of population is, or as the capacity of population, that will be, the possible, or as the capacity of population of one particular zone is already defined. Once the zone is developed, we'll go for the next zone. That means if the area is developed, if the area reaches to the population what is already assigned, or is what is already defined. Once the area is filled, we'll go for the next area. Here in the past area, with respect to population, with respect to water demand, with respect to all the facilities will be given. Once the zone is occupied, we'll move to the another zone, or else we'll move to the another area. That means what the development of the previous zone is clearly indicating the population of that area, because that is already pre-planned in the name of master plan. That's what I mentioned here. Through master plan, density of population, total water demand and wastewater generation for that respective zone can be worked out, because the zone is already defined with respect to population, with respect to the water demand before it started development. Once the zone is filled up, we have the possible capacity of population, and once we got, or else once we came to conclude that this area is filled up, and as per the master plan, next area will started to initiate for the development. That is what about this master plan method. And as per the master plan method, the development will be area wise, because it is already as per the master plan. Once area A is started development, and we have already the predicted data up to what extent of population this area is feasible. Once we come to conclude this area is filled up, we'll go to the next area to be developed. Likewise, we may have the master plan with respect to the developmental activities, where the population, the water demand, and all other activities are prerequisite. All activities are inbuilt. This is what about the master plan. We have discussed with respect to, as a continuous part of population forecasting, we have discussed graphical method, where the graphs are used to predict, whereas the comparative graphical method, here the population in volume with respect to number taken along with the graphs the future population of the similar cities will be predicted. And master plan method, the master plan which is designed for 25 to 30 years, where the area has been divided into various zones like industrial, residential, commercial, so on. Once the area is filled up, we know the capacity of population of one particular area before starting development. Once it started, once it is occupied, once it got developed, we'll move to the another area where we can get the population of the previous area. Likewise, we can predict the population with respect to master plan method. With this, we have closing the topic population forecast, where we discuss all these 6 methods, and of course other methods also there. As per the curriculum, 6 methods are enough, and other methods also there like logistic curve method, something like that. But here these 3 are the problematic, and these as per the formulas, and these 3 are will be as per the predictions which we have the data of previous. These 2 are we are just taking into the consideration of similar cities, whereas the master plan as per the blueprint which is designed. That means we have the combination of various methods where we can find out the population of future decades in the name of population forecasting. Now we go to the next topic, sources of water. With this, we are finished the introduction part, or else unit 1, where we discuss the necessity and importance of protected water supply, objectives of protected water supply, waterborne diseases, role of environmental engineers, water demand, factors influencing water demand, and types of water demand, per capita demand, design period, factors influencing design period, and population forecasting. Of course, we also discussed estimation of water demand. With this, we are finishing the first unit and we are moving into the second unit, sources of water. You know, when we have a look, I told you in the beginning itself, this here flow chart of water supply system. Here we are here now. We are here sources of water. Up to what we discussed is just as part of introduction, which is inbuilt of unit 1. Now we are slowly entered into the second topic, that is sources of water. Here, by the name itself, you can easily find out, easily can get an imagination. Sources of money for you, maybe from your parents. Here, likewise, sources of water. What is the source? Simply here, the source of water will be two possible ways we have for the source of water. One is surface water, another one is groundwater. Water which is available in the name of ponds, lakes, rivers, reservoirs. We may call it as surface water, and water which is available in the name of springs, in the name of aquifers, or else in one word, water which is available in the deeper ground, we can call it as groundwater. See, when we have an attempt to make with respect to quality and quantity, with respect to quality, groundwater is good than the surface water. With respect to quantity, surface water is more than the groundwater. See here, that's what I mentioned here. Water is the second essential component after the air for the survival of any living organism. See here, the total availability approximately 97.3% is in the form of oceans, which is unfit for human consumption without treatment. Whereas the surface water quantity is here. The next point is surface water quantity is more than the groundwater, whereas in quality perspective view, groundwater is good than the surface water. Now we'll discuss about surface water. I told you, and easily you can imagine what is surface water. I told you just now, the form of lakes, rivers, etc., called as surface water. We'll move accordingly as per your curriculum. First one of surface water is lake. See here, these are natural water basins originating from the top mountains or hills. Normally, type normally basins or catchments holds where the impermeable strata which won't allow shrinkage and seepage of water. How they are forming? Simply they are originating from the top of mountains whose bottom is impermeable membrane which may not allow the seepage of water, which won't allow shrinkage. This is the first prerequisite of lake. And next one is these catchments will be filled up with water which comes from the nearby springs and streams. Here it depends on the quantity of lake water, depends on the availability of water in the springs and streams. One more time. The lake, from where it is originating, from the top hills, originated from the top mountains or hills, and whose bottom is made up of impermeable membrane, which won't allow the seepage of water as well as which won't allow shrinkage. And possible source of this water to these lakes or springs and streams. The quantity of water in the lakes depends on the availability of water from the streams and springs. This is what about the lake. The next one is the river. You know it. What you may have, we have a nearby river, the Krishna River. The origin of rivers is always at high altitude of mountains where they start with minimum flow while they are flowing. What I can say is the width will be increased with respect to the depth. The primary reason for the extinction is merges with small water bodies, and while it is moving, it becomes one large moving water body while it is moving forward. As the rivers hold the self-leading capacity, river water is suggestible for the consumption than the water from the seas and oceans. One more time. See here, the lakes are origin from the top of hills, whereas the origin of rivers is high altitudes of the mountains, which starts with a narrow flow, with a minimum flow, and it expands slowly when it is moving forward. While it is moving forward with respect to width, with respect to depth will be depth will increase. As the rivers holds self-feeding capacity, when any attempt to drink water for consumption, the river water is more suggestible than the ocean, whereas than the water that is available in the name of seas. Next one is impounding reservoirs. The topic is impounding reservoirs. See here, reservoirs in the sense here, availability of water. See why we are going for these reservoirs. Sometimes we are observing the heavy rainfall at one particular year, and we may not observe the rainfall in the next few years. In such cases, if we are able to hold the rainwater and we are able to save the rainwater in the name of reservoirs, we can use that water for further usages. Simply, the reservoir normally during summer period, just now I explained, during summer period there will be a scarcity of water, and which may not meet the demand of water of the public. In such cases, the rainwater will be stored by constructing a constructing a bond across the rivers, constructing a bond across the rivers, which we may call them as impounding reservoirs. See, what I am clearly mentioning is here, the lakes, for the lakes, they are origin from the top of the hills, rivers also from at high altitudes of mountains, whereas the reservoir, impounding reservoirs in the sense, the water availability will be minimum during the summer period, and because of the various existed atmospheric conditions. In such cases, we must use the water that is available in the rain, the name of rain, so that the future will be in a good condition with respect to water. The way of storing water by constructing ponds across the river, we may call it as impounding reservoir. Mostly it is found there is a great variation with respect to quality for summer and rainy season, because the nearby runoff during rainy season contaminates the river water, whereas during summer season we may not find out the rain. Mostly the runoff is minimum. That's why water quality in the reservoir is good during the summer period, whereas it will be contaminated with respect to season, because with respect to season due to the activity of runoff. See here, to overcome the to overcome the problems that are associated with the water availability, we may construct burns. We may construct the concrete burns across the rivers, which may call them as impounding reservoir, simply storing water during rainy season, and that will be useful. That will be used in the next season to overcome the problems associated with the water demand. This is about the impounding reservoirs, and here specification to select the site for reservoirs. I said this is impounding reservoir, nothing but constructing a bond across the rivers. Now, what are the specifications to select to construct? The first one is the selected site must be narrow, but it should be widened. It should be rapidly widened towards the upstream direction. Yet the selected site must be narrow. In that particular narrow, we can construct while it is moving. It should be widened rapidly. That area must be selected to construct the reservoir, and the location must have the possibility of storing water, which may, in the name of rainfall runoff, which may depends on the intensity of rainfall. That means what I'm speaking is here, the site location must have the possibility of storing large quantity of water, which may depend on intensity of rainfall, runoff, and catchment area. And third one is that should be feasible for releasing water under gravity. The location must be feasible to pass the water under gravity. And next one is it should be away from the cities and towns to overcome the problems associated with compensative settlements. And the construction material must be available nearby to the selected site to overcome the problems associated with transporting charges. And it should not contain salts. It should not contain any contaminated soluble salts, which may disturb the quality of water. And the site must be away to the flood zones and should be favorable for construction of. The topography should be favorable for construction of dam or reservoir, and that reservoir must be free from the possibility of local contamination, which may occur because of the washing of clothes, bathing animals, etc. And the selected site must be free from the geological conditions like folds and faults. One more time, we'll go back and we'll discuss about the specification to select the site. The first one, that should be narrow and should be widened rapidly when towards the upstream direction, and the second point, the selected site must be capable to store more and more rainfall. And the third point, it should be feasible to release the water under gravity. And the fourth point is it should be away to the towns and cities to avoid the problems that may associated with the compensative settlements. That means if the area is selected near in the towns and or else in the cities, we need to vacate the occupants, where we need to vacate the occupants by giving some compensation. To avoid such compensation settlements, the area must be away to the cities, towns, any parks, cities, towns, etc. Such type of categories. And next one is that the constructing material must be available to the site to avoid the transportation charges, and that particular area should be free from the soluble salts to maintain the quality of water. And that selected site must be away to the flood zones, and it should be free from the possible local contamination which may occur because of the washing cloths and animal bathing animal, something like that. And the site must be free from the geological conditions like faults and faults. By keeping in view of all these points, the site must be selected to construct the reservoir. See what we are discussing here in the name of sources of water. As we entered into the second, the first topic is sources of water. The first one is surface water. In the name of surface water, we have discussed lakes, rivers, impounding reservoirs. In the lakes, we discussed what is what. Reservoirs, we discussed what is what, and we are discussed what is reservoir, and and also we discussed the site selection criteria to construct a reservoir, which is a part of surface water. See here, next class we'll discuss about the other category in the name of source of water. We discuss surface water. Obviously, the next topic will be groundwater. Today we have discussed the topics which are left in population forecasting by name, graphical method, comparative, next one, comparative graphical method, and also we discuss master plan method. With this, we finish the first unit and enter into the second unit. In the second unit, we are slowly entered into the topic uh, with respect to water supply system. Of course, first unit itself you entered, but here, from here onwards, we'll discuss various units or else various associated topics that are linked with this water supply system. As part of this unit, we discussed about the topic sources of water. We have finished the first topic, surface water. The next class, we'll discuss about groundwater. If you have any doubt, you can contact me either phone or mail or message. Thank you.